Hello, this is Mrs. Bentley, and I'm here to work out 5 more of the problems with you guys that will be on the released EOC packet. So if you can turn to number 35, we are asked what are the solutions to the equation 4x squared minus 52x plus 169 equals 121. Again, always look at the equation. Look to see what your highest degree is. The highest degree in this equation is 2. We have an x squared, so we know we have a quadratic equation. This equation is on the calculator active part of the test, so we are going to solve using the Desmos graphing calculator. Now, before we solve, we need to make sure the equation is in standard form and set equal to 0. And if you notice, this equation is equal to 121. So in order for this equation to equal 0, we're going to subtract 121 on both sides of the equation. And if we calculate 169 minus 121, that's going to simplify to 48. That's going to simplify to 48. Okay, so we're going to bring down the remaining equation. We have 4x squared minus 52x plus 48 now equals 0. You could use factoring. You would want to look to see, is there a GCF? And there is a GCF, let's see, of at least 2. So you would factor out the GCF and then use your Xbox method. Since this is on the calculator active section of the test, I would go over to your Desmos calculator and type in the equation y equals 4x squared minus 52x plus 48. And at the time, I do not see my graph, so I'm going to make sure my graph is centered. You can set the graph back to the default screen by selecting the home key. There is part of my graph. I can then zoom out to see if there is another solution. Remember, with quadratics, we call the solutions zeros. So it's the value of x when y equals 0. So here's one value. We have the 0.10, so 1. X equals 1 is a solution. And the other answer is x equals 12. So the correct answer is answer choice D. Okay, if you'll flip to number 39, we are given 2 functions. They're shown below. We have one function identified as f of x equals 3x plus 7. The second function is g of x equals 2x plus 12. The question asks, what is the value of x? So we're looking for x where the graphs of f of x and g of x intersect. So remember, anytime we enter an equation into Desmos, you're going to change your function notation to y. So we're going to change the f of x to y equals 3x plus 7. And on line 2 in Desmos, we're going to type in the g of x function, still using y equals 2x plus 12. We are then going to identify the point where the 2 lines intersect. And the question is only asking us to find x. Okay, and the window range that I had set for my last problem actually works for this problem. If it did not, you may want to hit the home key just to go back to the default and then zoom out or zoom in as needed. So if we click the point where the 2 lines intersect, our ordered pair is 522. Remember, the first number in the point is your x value, so the answer is 5. So that's going to give us answer choice C. Notice they do have 22 as an answer choice, so make sure you pay attention, close attention to the instructions on whether you're asked to find x or y. Okay, we're now going to take a look at question 41. It says a function is shown below. G of x equals 19.60 plus 1 1.74x, and they're asking you to evaluate to find the value of g of 30. We haven't talked about function notation in a while, so I just wanted to go back and revisit this problem so you can easily understand how to substitute the 30 in for x and simplify. So g of x, remember that's just replacing y, and the value inside the parentheses is the value they're wanting us to evaluate the equation, and we're going to substitute 30 in for x. So the equation is 19 and 60 hundredths plus 1 74 hundredths, and where you see your variable x, we're going to substitute 30. So now you're just going to calculate. So we're going to keep the 19 and 60 hundredths. We're going to always do the multiplying first and then come back and do our addition. So if we simplify this, we have 1.74 times 30, and that calculates to 52.2. And now we're just looking for the sum of 52.2 plus 19.60. So you get the answer 71.8. Just a quick review of function notation. So if you're given a function and they have a number inside the parentheses, that is the number you are substituting in for x. If they give you what g of x equals, you would substitute that value in where g of x is, and you're solving the equation to find x. Okay, we're taking a look at number 42. The table below shows the weights of 8 different bears at a zoo. So if you look through the list, you're going to see in the first column the type of bear, and in the second column the weight. So the type of bear is our independent, or our x variable, and our weight is our dependent. Now it says, if the weight of the polar bear is removed, which statement is true? A says the mean decreases more than the median. B says the mean decreases less than the median. C, the mean decreases more than the median. And D, the mean decreases less than the median. So if you think back to today's lesson on Friday, Ms. McNary went over with you how to enter data into your Desmos calculator. Again, I'm just going to stick with naming this List A. And remember to use the square brackets. You're going to type the data set, making sure to separate each number with a comma. So give me just a moment to get the data entered. Okay, and it's showing we have 8 elements in our list. So let me just count the table on the problem and make sure that's accurate. So 1, 2, 3, 4, 5, 6, 7, 8. Again, I would also scroll back through your list. Just make sure you type the numbers in correctly so we don't miss this question just by user error. So we have 225, 300, 550, 200, 1,000, 300, 280, and 100. So that looks good. Now if you notice, all of the answer choices are comparing the mean and the median. So we need to calculate the mean and the median of the data set. So remember, we're going to go to functions. Make sure the keyboard is open. If your keyboard is not showing on the screen, you can click the bottom left corner button, and that's going to open up. And we're going to select functions. We're going to select stats. And let's do our mean first. Oops, I made that mistake of not going down to a new line. So hold on, let me delete that. Going to the second line in Desmos. Let's try this again. I'm going to functions, stats, mean, and we're wanting to calculate the mean of list A. So right now the average weight is 369.375. Okay, we're going to go down to line 3, back to functions, back to stats, and now we're calculating the median of list A. and the median is 290 pounds. Okay, so let's make sure we write these numbers down on the problem. So we have a mean, I'm going to use X bar for short. That's 369.38, and our median is 290. Okay, the problem is wanting us to remove the polar bear's weight. So if you look at your table, the polar bear is 1,000 pounds. So we're going to go up to our data in our list A, and we're going to find 1,000, and we're going to delete that weight. So notice the number of elements in the list changed to 7 because we removed one of the weights, and as we did that, our calculations also changed. So you'll see that the new, I'm going to change colors, the new mean equals 279.2. We're going to round that up to 929, and our median equals 280. So just kind of make a note of what's happened here. The original mean was 369.38. The new mean is 279.29. So this was definitely a decrease. The median dropped from 290 to 280, so also a decrease, but not nearly as much. So let's look at our answer choices. A says the mean decreases more than the median. That is true because the polar bear is a high outlier. So far I definitely agree with A, but let's make sure there's not a better answer. B says the mean decreases less than the median. That's not true. The mean decreases more than the median because the high value balances the low value. No, that's not true. And the mean decreases less than the median because the high value balances the low value. And that's also not going to be true. So we've got to think about that 1,000. If you look at your list of numbers, that 1,000 really stands out as the outlier, the oddball. So the best answer is definitely answer choice A. Okay, we're taking a look at number 45. This will be the last one that the video will go over, so make sure you complete those 5 problems in your packet, and anything else that has not been completed, go in and at least try to do those problems. You will only be graded on the problems we have worked on together in class or through this video. So number 45 says, what is the distance between the y-intercept of the function f of x equals 2x squared minus 6x plus 3 and the y-intercept of the linear function g represented by the table below? So we have a quadratic equation. I'm going to go ahead and actually put that into Desmo so we can just see what the graph looks like. We have y equals 2x squared. And then, let's see, minus 6x plus 3. Whoops, I didn't hit plus. Okay, so you should actually be able to determine the y-intercept of this function. I'm going the wrong direction. Here we go. You should be able to determine the y-intercept of the function just from looking at the equation. Remember, the c value, that plus 3, is also your y-intercept, but you can see the graph. We do have the y-intercept at positive 3. So the quadratic equation's y-intercept is at positive 3. Now, I'm going to show you a trick with the linear function. We have a table of values, so we're going to click the plus sign, and we are going to, instead of entering an equation, we're going to enter the table of values. So select table, and under x1, you're going to type in your negative 5, all of your x coordinates, negative 2, 2, 5. Under list 1, you're going to type in 15, 3, negative 13, and negative 25. So those points are on the graph. Now, I'm going to zoom this out for just a moment. So there are the points of the linear function. Now, right now we're only seeing the points. If you take your pointer and hold the circle down on that black circle, you will see where we can turn on the lines. So you're going to turn the line on, and that's going to actually connect our points so we can see where the linear function crosses the y-axis. So this line has a y-intercept at -5. Now, if you look at the graph, I was going to try to see if I could get a good window where we can see the y-intercept of both. Let me erase this little dot for just a second. That's probably going to be the best I can, probably the best I'm going to be able to get in order to fit both. So we have one y-intercept at -5, and we have one y-intercept here at +3. We're wanting to know the distance between those two y-intercepts. So if you count, here's 1, 2, 3, 4, 5, 6, 7, 8. So the distance between the two is 8 units. You could also just say, what's the difference between 3 and -5? So 3 minus -5, that changes to 3 plus 5. That also equals 8. Well, thank you for listening to my video. I hope this helps, and good luck on your exams next week.